In this video, I'm going to show you how to get started with Cluster1 using a self-driving car demo. The content of this video closely follows what you can find in our Getting Started documentation page you see here. The first step is to fork the code we'll be using from github.com/cluster1/self-driving-demo. So I'm going to go ahead and fork this repo. Okay, now as you can see, the repository has been forked to my GitHub account. Now I'm going to go to Matrix, the graphical user interface for Cluster1, in order to link my GitHub account. So if I go to the top right corner here and click on Access Keys, we see there's a block for GitHub where I can enter my username and personal access token. To generate a personal access token, go to your GitHub page and in the drop-down menu on the top right corner, click on Settings. Then on Developer Settings, and then on Personal Access Tokens. And we're going to click on Generate New Token. We're going to give our token a name, and then it's important to click on the scopes for repo and admin:repo hook. Go ahead and generate that token. Copy the token so you can input it into Matrix. I already generated a GitHub token for my Cluster1 account, so I'm going to delete this one. Now we're going to create a project using the self-driving repository we just forked. So in the Projects tab, click on Add New Project. Then click on Use Existing GitHub Repository. And go ahead and start typing in the name of the forked repository. Then once it's found, click on Add Project. Now that the project is created, we can create jobs using the self-driving code. You can click on the repository tab to confirm the project has been created correctly. So now we're going to go ahead and create a job under this project. On this first page, I usually don't change anything because I typically use the latest commit from the master branch, but I do like to provide a meaningful job name. This helps you keep track of the experiments you run. We're going to skip adding a dataset. The reason being, for this example, we're going to use a public dataset. Cluster1 provides access to several popular datasets like ImageNet, Cypher10, and the self-driving car dataset that we'll be using. These datasets are mounted to every job, so there's no need to link to them. The datasets can be accessed by simply referencing the /public/ directory in your code. You'll see in the next step how this can be done when we pass the self-driving car data directory as a command line argument. And we're going to specify the configuration of our distributed job starting with the type of Docker container our workers and parameter server will be using. Then we want to specify the command that will be executed inside the Docker containers. Namely, we want to kick off the Python code that will be used to start training a network on the self-driving car data. Notice how in our command we're passing in /public/self-driving demo data to the argument named absolute data path. This is the public dataset access point I was referring to in the previous step. Specify your environment setup command. We have a requirements file in the GitHub repo, so we'll use that to install all libraries we'll need. In the final step, we'll specify how long we want our job to run, the type of hardware we want to run on, and we specify the number of parameter servers and workers we want to use for our distributed job. Sometimes it can take a few minutes to get a job going. You can see the status of everything that's going on behind the scenes by clicking on the Events tab for your job. I'm going to add this job to TensorBoard so I can get live feedback on how the training is going. When all resources have been gathered to execute your job, you'll see that the job state is changed to running. At this point, your code is actually being executed and logs are being generated. You can look inside your logs to see what's going on by clicking on the Outputs tab. So here in the parameter server log, we see all the libraries that have been installed as specified in our requirements file. As the model gets trained, we eventually find model checkpoints in the output. Let's see how the training is going in TensorBoard. One good metric to keep track of during distributed training is the number of global steps per second. This metric can show how much speedup you're getting by leveraging multiple workers and parameter servers. That's all there is to it. When your job is done, you'll find the status has been changed to stopped.